So here is a practice problem for ISI PE. Okay, so let's do this, and based on this, I'll be providing you another question from the ISI papers itself. Okay, which you can do as a practice as well. Okay, so let's see the question. A function fx is defined as taking its value from the limit of 1 by 1 plus x to the power n as n tends to infinity, and it is defined for positive x. Okay, so this function is equal to limit n tends to infinity for 1 upon 1 plus x to the power n. Okay, and it is defined for x more than equal to 0. Show that the function is discontinuous at x equal to 1. And what is the nature of discontinuity? Okay, so let's do this. So we know that this x to the power n as limit n tends to infinity. It is the value of this depends on whether this x is a fraction between 0 and 1, or is it exactly equal to 1, or is it more than 1. Okay, so depending upon these three cases, you will get different values of x to the power n. Okay, so let's first understand that. So suppose I take a case where x is a fraction. Okay, it is a fraction between 0 and 1, including 0. So point is that, let's say I take a number like 0.5. If I take its square, it will be equal to 0.25, right? That means squaring of a fraction between 0 and 1 is, by doing that, we get a smaller number than the initial one. Similarly, if I take a cube of it, okay, then I'll get 0.125, which is even smaller than the square. Okay, so that means if you keep increasing the power, you will keep getting even a smaller number. Okay, and when this power goes towards infinity, this will actually go towards 0. Okay, so when x is between 0 and 1, then limit n tends to infinity of x to the power n is actually 0. It goes to 0. Okay, let's take second case. When x is exactly equal to 1. Okay, so when x is exactly equal to 1 and we take limit n tends to infinity of x to the power n. Okay, basically it will be equal to limit n tends to infinity 1 to the power n. Okay, so ये limit है. Okay, not exactly 1 to the power infinity. It is when n is goes towards infinity. 1 to the power infinity is indeterminate. Okay, here we have limit n tends to infinity of 1 to the power n. It is actually equal to 1. Okay, because so what's the value of 1 to the power 1, and that's 1. What's the power of 1 to the power 2? That's 1. Okay, and it keeps on going. Okay, so you are not actually getting 1 to the power infinity. It is going towards infinity. So this is actually going towards 1 only. Okay, and case 3, when x is greater than 1. Okay, so when x is greater than 1, so let's take 2 as x. All right. So what's the value of 2 to the power 2? Well, that's it. That is equal to 4. What's 2 cubed? That is equal to 8. 2 to the power 4, it is equal to 16. And this goes on. Okay. So basically, as you increase the power, the value keeps on increasing. Okay. And as you go towards infinity, this will also go towards infinity. So in this case, limit n tends to infinity of x to the power n will go towards infinity. Okay, so now we'll be using these for finding out the value of this function in different cases. Okay, so now let's see this. So limit as n tends to infinity 1 upon 1 plus x to the power n will be equal to what? So let's take all the cases. So when x is between 0 and 1, okay, we know that this will go to 0, okay, and if this goes to 0, this whole function goes to 1. So this is equal to 1. When x is exactly equal to 1, this goes to 1, so 1 upon 1 plus 1 will be equal to 2, okay, 1 by 2, yeah, 1 upon 1 plus 1, it is equal to 1 by 2. And when x is greater than 1, okay, then this goes to infinity, so 1 upon infinity is equal to 0. ठीक है? 1 upon 1 plus infinity, which is equal to 1 by infinity, which is equal to 1 upon 1 by 0, which is equal to 0 by 1, okay, which is equal to 0. So this is equal to 0, okay. So uh, this is actually the function, right? Because this function, the function takes the value from the limit, okay. So let's draw this. So here we have x, here we have y, or the function itself, okay, and let's take 1 here, 0 here, okay. So when x is between 0 and 1, when x is between 0 and 1, this function takes value 1, ठीक है, and okay, at exactly 1, it is equal to 1 by 2, which is, let's say here, okay, and when x is greater than 1, it is equal to 0, okay. So clearly it is discontinuous at 1, right? Before 1, it is defined everywhere and it is continuous, okay. After 1, it is defined everywhere and it is continuous, right? Exactly at 1, you can notice that left hand limit is different than the right hand limit, right? How do you check the discontinuity? So you need to check the left hand limit, you need to check the right hand limit and the value of that function at that point, okay. If they all three are equal, then the function is continuous at that point c, okay, otherwise it is discontinuous. So let's c equal to 1, okay, and let's check that. So what is the left hand limit? So it will be equal to limit x tends to 1 minus of fx of this function, okay. So for any number less than 1, the value is equal to 1, okay. So directly it is equal to 1, okay, because these three values are nothing but the value of the function. So it is actually fx, okay. So it is equal to 1 when x is a fraction between 0 and 1. For exactly 1, it is equal to half, and for more than 1, equal to 0. So this is the left hand limit. What is the right hand limit? So limit x tends to 1 plus जब आप इस function को approach करोगे from the right, okay. So for any number greater than 1, it takes value 0, okay. So it is equal to 0. And what is the value of this function exactly at 1? It is equal to 1 by 2. Okay. So which clearly means that this function is discontinuous at 1. Okay. Function is discontinuous at 1, right? And there was another question asked there. What is the nature of discontinuity? So either this discontinuity can be removable or it can be irremovable, okay. But since in this case even LHL is not equal to RHL, okay, they both are not equal. Point is कि अगर मैं डिफाइन कर दूं 1 के लिए इसे इक्वल टू 1, तो भी ये डिस्कंटिन्यूअस रह जाएगा, ओके। और अगर मैं इस पॉइंट को यहां लेकर चला जाऊं, इफ आई पुट इट हियर, आई से दैट ओके, लेट मी रीडिफाइन दिस फंक्शन एंड इट विल टेक वैल्यू 0 एट 1, ओके, देन आल्सो इट विल रिमेन डिस्कंटिन्यूअस। सो नो मैटर मैं इसे इस 1 की वैल्यू के लिए for x equal to 1 मैं इसे कहाँ define करूँ, it still remains discontinuous. The reason being LHL is not equal to RHL. Okay, so let me take an example. So suppose discontinuity is like this कि एक particular point कहीं और है but LHL is equal to RHL. What you can do is you can redefine it. आप इस point को pick करके यहाँ वापस put कर सकते हो and now it becomes continuous. Okay, so this kind of discontinuity is called removable discontinuity. But अगर RHL और RHL or LHL unequal, like in this case, then I cannot redefine this function to make it continuous. Okay, so since LHL is not equal to RHL, the function, the discontinuity is irremovable. Okay, so in this lecture, in this video, you got to revise discontinuity, okay, and removable and irremovable discontinuity. Now, based on what we just studied, you can practice this question of ISI 2004. Okay, so here the function is equal to x to the power t minus 1 upon x to the power t plus 1. Okay, and the limit of the function as t tends to infinity, and these are your options. It does not exist and is everywhere continuous, exists and is discontinuous at exactly 1 point, exists and is discontinuous at exactly 2 points. So do solve this problem and comment that what answer have you got. Okay, A, B, C, D. All right.